What we're looking at today is experimental probability. Now we also call that relative frequencies. So frequency means how often something happens. Relative means how often something happens relative to something else. So for instance, if we tossed a coin and we tossed it 10 times and we got 7 heads and 3 tails, then the relative frequency of getting a head would be 7 out of 10. The relative frequency of getting a tail would be 3 out of 10. So normally what we've dealt with up to now is what the probability we've looked at is called theoretical probability. And it is normal that what has happened with that is that if we've got a coin, we know we've got a 50% chance of getting a head, we've got a 50% chance of getting a tail. If we have a dice, we know we've got a 1 in 6 chance of getting something. But there's lots of things that we can't just look at and work out. What we need to do is we need to do an experiment, an observation, to work out what the frequency is. So an example of that might be, for instance, if we wanted to work out what the relative frequency of teachers driving SUVs, then what we might do is go down to the car park and count up all the cars, that would be the total number of cars, count up how many SUVs we've got, and then the relative frequency would be the number of SUVs on top of the total number of cars. Okay, in this one though, we're going to look at probably both things. So with our experimental probability, what we always have on the bottom is the number or the total. So it's going to be the total number of times that we flip a coin. It's going to be the total cars in the car park. It's going to be whatever we're looking at, the total number of times we do something or items that there are. On the top is going to be the number of favourable outcomes. That is the number that occur for what we want. So again, if we're tossing a coin 10 times, we're going to have 10 on the bottom. If we get 7 heads and we want to see what the probability is of getting heads, we will have 7 on 10. Okay, so experimental probability is the number of times the outcome occurs. So we'll go outcome on top, and then it's over the entire total. So if I'm looking at these examples, then we'll go through them. So the other thing up there is say, once we have worked out what our experimental probability is, so for instance, again, if we're talking about getting heads, if we decided we tossed them, we got 7 out of 10, that's our experimental probability. We're going to assume, even though we know it's wrong, our experiment says that every time we toss a coin, we've got a 7 out of 10 chance of getting a head. So if somebody said to us, how many heads would we expect to get if we toss the coin 200 times, we would go 200 times 7 out of 10 every time. And you could put that in your calculator and what you'll get is 140. So we would expect to get 140 heads if our experimental probability we found was 7 out of 10. And then for tails, it would be 200 minus that. We would expect to get 60 tails. All right, so let's have a look at these first examples. The first example says that Chris plays rugby and has a record of kicking a goal from a penalty kick 4 times out of every 7 attempts. So every time he lines up, every 7 kicks that he has a go at, he gets 4. So getting the experimental probability or the relative frequency for that is going to be total number of kicks, 7, put that on the bottom. Total number he gets is 4. That's the answer. Now, if they ask us, if he takes 28 kicks at goal, if we want to see how many we expect him to get, we're going to have 28 kicks at goal. We're going to times that by the relative probability we found, times 4 on 7. Put that in your calculator and you will find, so 28 times 4 over 7 in your calculator, you'll find the answer of 16. All right, so then the first thing you want to do is you want to do these first, I think, 3 problems. So looking over here, it's about basketball. Ashley has found she can shoot a basketball through the hoop 4 times out of 10. So the first thing you need to do is write down the experimental probability. So write 3A in your book and then we want the how many experimental probabilities. So you're just going to be writing down. Total number is 10. You're going to put that in the bottom of your fraction. On your top of your fraction, you're going to put 4. Then you're going to put that in your calculator, 4 over 10, and see if it simplifies. Write the answer in your book. That's the first one. Now the next one you're doing, 3B, is going to be the expected number of times the ball will go for the hoop from 100 shots. So you're going to multiply what you got in A by 100. It's going to be 100 times this answer up here. You'll put that in your calculator and you write the answer in your book. Okay, so the next question, 4. What it's asking you to do, it's saying experimental probability of Jess hitting a bullseye on a dartboard is 5 for every 100 times she throws it. So put that down as a fraction. 5 over 5 out of 100. Put your 100 on the bottom, your 5 on the top. Put your equal sign in your calculator. Right over here what the simplified fraction is. Okay, so now what they're asking you to do, so write that first before you get anywhere to doing this, and then you've got a whole series of questions. So for all that, it's asking you how many times bullseyes you'd expect for a certain number of darts. So the first one says 100, so it's going to be 100 times. Now the next ones I'm just going to read out to you so that you write them down. The next one is 200 times. Write that in your book for B. 1,000 times for C, and D is 80 times. So you're going to write them down in your book and then multiply it by this fraction that you had up here and then put your answer in. Now question 5. We've got a bus company surveying a random selection of 90 people in one suburb. Remember, that 90 is the total. That 90 is going to go on the bottom of your fraction. They found that 35 of these people regularly used a bus service from that suburb to the centre of the city. Put 35 on the top line of that fraction in your book. So that's the first thing you're going to write down, is what I've just said. Then put that in your calculator, push equals, and write down the simplified fraction on the right-hand side of that. Question A, state the experimental probability for a person in that suburb to use a bus service regularly. That is the what you've just worked out up the top. Write that in. And the next thing is, if there are 2,700 residents in that suburb, find the expected number who would regularly use a bus service from that suburb to the city. So you're going to have that number, 2,700, times what you got up the top here, times this one here, which is the answer to A. Okay, that is the end of chunk 1.